three quick things as you go into your test. Traffic light, definitions, unitary method. What are we talking about here? Okay, so traffic light. You've got two topics in your exam. We've got ratios and rates, that's one of them. And we've got our fractions and percentages and all that. Okay. Now, what I like to do is I like to grab three colors. Green, yellow, I don't have yellow, so I'm using orange, and red. And this just kind of indicates my ability at each of these different topics here. Probably what a red marker actually works, so I'm sure you can find one, right? If you kind of tick it, hey, I'm really good at ratios and rates, I can do that. Fractions, not too good, I might circle that, right? And if you have some other thing that you're not very good at, like maybe dividing fractions you're not very good at, we'll put a cross there because that's the one I have most difficulty with. Now, I've just got those broad topics there, but on your little notification sheet, looks like this, right? You can actually have the subtopics and skills that you need for that. So you can go ahead and do it for each specific skill, which is really good. Definitions. When you're asked to do certain things in your test, for example, simplify, you have to know what that means in each kind of context, right? Or if I'm asked to evaluate, what's that really asking for? Evaluate. I'm asking to really get an answer, but a numerical answer to a particular question, okay? If I want to simplify a rate, right, we're really looking, can you make the numbers as small as possible as whole numbers or integers, right? So reduce the numbers. But we're not changing the actual ratio that's there, so reduce the numbers. What else is it? Well, GST is a great one, right? The goods and services tax, what is that? That's 10% of the original price. So often when you get a price of a product, that's already got the GST factored in. Okay, so just kind of keep that in mind, that kind of knowledge there, like the GST is the fact that we're adding 10% on top. When you're purchasing something, you're really paying 110% of the original price, right? Unitary method. This is a great thing to use when we're looking at the topic of ratios and rates. Right? Anytime you want to find a particular percentage, it's actually much easier to go down to 1% and then go from there. Because from 1%, you can find any other percentage much more easily than if you were given a different kind of percentage. I'll give you some examples of that. All right, simplify. What does simplify mean? I know that. Right? We want to reduce the numbers. So if I have something like this, the thing I want to think about is what's in common. Now you look at this immediately and you say, oh, 3 goes in 6, easy, right? I can just say that's just 1 to 2. That's how I can simplify this rate, right? Now, when you're doing this, what you're actually doing is, just keep that in mind, you're actually dividing both sides by 3. You may not need to actually do that in your calculations, but it's useful for stuff like this when we move on, right? 18 to 12, well, they don't divide into each other. But still, go back to this question. What's in common? And I can see that in common here, well, they're both even, so 2 is in common. Now, you can reduce and divide both sides by 2, but if you do that, you'll notice you can reduce them again, right? So really, you want to think about what's in common and actually the highest common factor, right? What's the highest common factor that goes into both these numbers? If you have a think about it, you'll realize it's 6, right? 6 goes into both 18 and 12. I'm going to divide both these sides by 6, and that will give me 3 to 2. Okay. Last one. I know how much you guys love fractions. With fractions, what you want to think about is, okay, I want to reduce these numbers, but I also want them to be whole numbers, right? So what can I do with these fractions to make them whole numbers? Well, fractions is really just division, right? So if you think about the opposite of division, it's multiplication. So if I can multiply these fractions by a certain amount, then I can potentially get rid of these fractions here. But the thing is, you don't want to actually change the ratio. So what you do to one side, you have to do the other. The easiest way to do it is you look at these numbers in the denominator and you say, well, if I multiply them together, I get 5 times 10, which is just 50. If you multiply both sides by 50, you're going to get rid of the fractions, guaranteed. So you can always use that skill. But sometimes you don't need to do that, because sometimes what you can do is you can find a smaller number, which makes the calculations easier, right? For example, I know that 5 does go into 10. So if I do multiply both sides by 10 here, okay, let's see what happens. I get 20 over 5, And then here I get 30 over 10. That's just using multiplying across the numerators, if that wasn't clear. And then, hang on, this looks quite nice, isn't it? We've got 20 divided by 5, which is 4. And we've got 30 divided by 10, which is 3. That's how you can simplify a ratio involving fractions. Try and think of a number where you can multiply both sides of the ratio by, so that we have whole numbers, and then you can simplify and reduce the numbers that way. Okay, equivalent rates. Now, with rates, right, we want to think, okay, I know that I've got 90 kilometers per hour. That's what I'm looking at over here. What if I want to know how many kilometers per minute? And what you want to think about is, hang on, I've got hours here. Well, I know that this is the same as 90 kilometers per 60 minutes, right? And this is this kind of idea of a unitary thing. You can go back to one single minute. Well, if I divide 60 by 60, that gives me to 1. So that's what you're doing. You're dividing this by 60. We can do the same thing to this side, right? So you put in your calculator 90 divided by 60, and then you'll get 1.5 kilometers per minute. And just be careful here, we're actually doing two conversions for this next equivalent, right? We're going from minutes to seconds, and then we're going from kilometers to meters. So there's a few things that's going on here. First of all, if I was to write this as meters per minute, just to make this, conversion easier, I could write this as, well, hang on, 1 kilometer has 1,000 meters. So I'm really just multiplying by 1,000 here, right? So I'll get 1,500 kilometers per minute. Or, if I do what I did out here, per minute, I can rewrite as per 60 seconds, right? So now I actually have to do one step after I've done that, right? So I just divide again by 60 in order to go from 60 seconds to just 1 second. I'll do the same to this side. So that should be meters. There we go. We got 25 meters per second. Okay, can you see how if I do everything step by step, it makes the calculations a lot easier. All right. One last question I wanted to do, and it's the classic one with this house thing. So we've got this scenario where to complete a job, all these people take a different number of days, right? Marek, he takes 8 days, Hugh takes 6, and Ethan takes 12. What if they all work together? How many days would it take them? Now, the inclination is you see all these people, you're putting them together, so you think about adding. But if it takes Marek 8 days, Hugh 6 days, and Ethan 12 days, obviously if they're working together, I should get a small amount of days. If I add these up, I get 26, which is, that doesn't really make sense. What we have to do is we have to think slightly differently. What we have to do is we have to think, how can we compare these guys all equally? They're taking up different number of days to do the job. So how can I compare them on a level playing field, right? What I want to think about is, what if I took the number of days, I tried to see how many times they could do the job in the same number of days. If I can do that, the comparison is a lot easier. I'll tell you what I mean. So I need to find an amount which 8, 6, and 12 all go into, right? As an example, if you took 12 days, right? If I took 12 days, Hugh could do 2 jobs, because he takes 6 days to do one, so he can do the job twice as fast as Ethan. So you can start to see, if I compare them in that way, it becomes a lot easier to put them all together. So 12 is an example I could use, but unfortunately 8 doesn't go into 12, so I need to think of another number. So have a think, right, what numbers do all of these go into? And if you think about your times tables, you've got 6, 12, 18. When you get to 24, well, how many times does 8 go into 24? 3 times. So really, in 24 days, right, how many times is Marek doing the job? He could do the job 3 times. How many times is Hugh doing the job? He could do it 4 times. And how many times is Ethan doing the job? He could do it, well, how many times does 12 go into 24? He could do it 2 times there. Okay? So in total, what we've got going on here is, if we gave all of these guys 24 days, I'm seeing how many times could they do the job all together. And how many times could they do the job all together? Now I can think about adding, because it makes more sense in that situation. So these times look like, let's just get rid of this. Okay. So how many jobs are they doing all together, right? Well, if we add these all up, we get 9. They're doing the job 9 times. So I mean, doing a job, that's it, vague. What are we doing? Maybe we're building a shed, right? So we've got 9 sheds going on here, right? So we've got 9 of these here. That's in 24 days. So if I want to think about how long does it take them to complete a job, well, let's write this out. We do 9 jobs in 24 days. This is actually just a rate now. What I want to think about is, how long is it going to take me to do 1 job? How do I go from 9 jobs to 1 job? Well, think about what we've been doing over here. We've been using ideas of rates, we've been using division. I'll divide both sides by 9. Okay, so let's put that all together. 24 divided by 9. We get a little fraction going on. So we have 2 2/3 of a day, I suppose, or let's say 2.666 recurring days. Either of those would be acceptable. So can you see how we have to shift our thinking a little bit? I'm not thinking about adding up these days, because that's not what I want to be comparing. I want to be comparing, right, how many jobs can they do in the same number of days. Once I've got that, I can add them all up together. That's a much better way of comparing them. And then I create this little rate here, that they do the job 9 times, or they do 9 jobs in 24 days, whether it's like building a shed or building on a table or something like that. So they can do 9 of them in 24 days. I want to know, if they're all working together, how long does it take them to do 1 job? And that's how I can get my answer, by creating this rate, then dividing both sides by 9 there. Okay? So hopefully that helps you out with ratios and rates. All the best with the exam.